Hey everyone, welcome to the channel. My name is Nader. In this video, we're going to go over a bunch of exercises for exception handling in JavaScript. In the previous video, we went over try and catch, as well as how to throw errors in JavaScript. This is just going to be a bunch of extra practice in order for us to better understand these concepts. So if you need more practice, definitely take a look at these exercises with me. Let's get right into them. Okay, so as with all the other exercises that we've done in this series together, I have a bunch of files pre-prepared with a bunch of comments at the top. And I'm just going to kind of read through the comments and kind of the scenario that we need to solve together. I'll give you a chance to do it yourself, and then we'll actually code the solution together to see kind of where we end up. So for this warm-up exercise is just to get our fingers warmed up. What we want to do is log out program started. Then we want to throw an error object with the message uh-oh. And then at the end of the program, we want to log out program complete. And then we want to run the program, and then we want to just watch it crash. We saw in the try catch video that this is actually just going to crash the program right here, because when we throw an error, that's kind of what ends up happening. So in order to kind of fix this, we learned the try catch block. So that's what we're going to do next. After you've seen this kind of crash the program, we want to surround all that in a try catch block with a console.error to log out the error, and then run the program again to see if there is a difference in how it actually runs and if we get to the program complete message. So go ahead and give that a shot, and we'll go through it together. All right, so at the very start, we want to do a console.log, and I'm going to log out this. I'll just copy it. It's easier for me. And then we want to throw an error object with the message uh-oh. So we saw that errors can be constructed in JavaScript using a new error, just like this. And then we can use the throw keyword, which we learned in the previous video, to actually kind of raise what's called an exception and cause our program to crash if nothing is catching this error. So if that's a bit confusing, definitely take a look at the exception handling video previous to this. So the message that we want to go through here is uh-oh. And at the very end of this code, we want to do a console.log of program complete, just like that. So you can see my editor is trying to be smart here and kind of tell us that it's not going to reach here, but let's ignore that for now. So if I run, make sure I'm in the correct directory first, then I run a node, and then I'll do warm-up exercise. So I know my face kind of cuts this off as usual, but you can kind of see right here is what we're interested in, right? We see program started, and then we run into this error, and then we see that this error is here, and then we see our uh-oh actually printed out right here. Okay, so in order to kind of stop this, because we're not seeing this printed out, because we never get a chance to get to this line in our code, we need to figure out how to actually catch this error. Okay, so what we can do to do that is we can surround the part that might be causing the error, in this case is 100% causing the error, in a try block. And then we can do a catch block, which will actually catch that error that gets thrown inside of the try block. Okay, so I can either put the program started out here or in here for the console log. It doesn't actually really matter. What matters is that this throw is inside the try block, because then it's going to look for the matching catch block to actually catch the error. So in here, I'm going to do a console.error, and I'm going to log out the error object that gets passed to us from the try block, which is going to be this error right here. So if I rerun this program now, we should actually see it run to completion and see our program complete. So we still get the error printed out, which is what console error is doing for us, but you can see that now we actually reach the end of the program and actually hit our program complete correctly. So kind of as we were programming this in the future, and we were kind of working on more complex programs, we'll actually do more than just logging out the error message. We'll try to recover from it, or maybe retry, or do whatever it is that we need to do to kind of make sure that our program is in the correct state and not going to cause errors in the future. But for now, this is definitely a very, very good head start on that concept. Perfect. So let's take a look at exercise 1. So for this one, we want to create a loop that loops 10 times starting at the number 1. Then on each loop iteration, we want to print out the loop number. Then on loop number 5, we want to throw an error object with the message boom, so similar to what we saw before. So this is just a different message here. Then we want to catch the error and console error the loop number and make sure that our loop goes all the way to the number 10. So effectively what I'm seeing here is we want to start at 1 and kind of go 2, 3, 4, 5, all the way up to 10. I want to be printing those out. And a special case on loop number 5 here, we need to detect that we're on the 5th loop, maybe using a conditional statement. and then throw this error message, but we got to be sure to actually catch it and console error it out so that we can actually continue all the way to number 10. So I'll give you a moment to try that out yourself, and then we'll go through it together. Okay, so I'm just gonna kind of do this without try catch to start, just so that we can kind of see how that works. So I'll do for, and I'll just say let I equal 0 here. Actually, I'll say 1. I is less than or equal to 10, and then I is gonna go up by 1 every single time. So our kind of condition is to print out the loop number every single time, right? So if I do a console log of I, I'll get my loop number printed out every single time, right? So we looked at this in the for loops video. So the special case here, though, is on loop number 5, we want to throw an error object with the message boom. Okay, so let's see. So we're going to say if I is exactly equal to 5, we want to throw a new error object, and the message is going to be boom. Okay. So if I run this code right now, what we'll see, and this would be exercise 1, we see that we kind of get 1, 2, 3, 4, 5, and then after 5, we get into that loop, or sorry, that conditional statement, and then we throw our error. There's nothing to catch our error so that we actually kind of fail, and the program just kind of stopped, and we never ever get a chance to go all the way to 10. Right? So how are we going to kind of fix this and catch this error and console error it out? So we could probably put this entire thing in a try catch block, but that might cause some issues because we want to actually be able to access the I variable inside of the catch block. So I'm going to show you real quick what this looks like. I'm actually just going to put the if statement inside of the try catch block. So I'll say try if I equals 5, throw a new error. And then I'm going to do a catch here, and this is going to catch the error object. And inside of here, I'm going to kind of put my console error. So in here, I want a console.error out the loop number, it looks like, right? So I don't want to actually log out the error. I want to log out the loop number. So just to make this super clear, what I'll say is this is error on loop number, and then I'll say a $sign here to template string this in so I can actually put in my I variable. So this should say error on loop number 5 in this case for us, right? Because this is only going to cause an error on loop number 5. So I'm going to just space this out a tiny bit more, and I'm going to run this, and let's see what we actually end up getting. So if we look at this, this actually seems to work correctly, right? Which is pretty amazing. The tricky thing here is if you tried to surround this entire thing in a try catch block, for example, like this, we did a try out here and we removed this one here. So I'll just comment this one out for now, comment this one out and this one out. If we tried to actually do a try catch like this, error, and I took this console log and I put it in here, all right, what we're going to end up with is an error, ironically. So if I run this, we can see that reference error I is not defined. Okay, and this is because if you think back to the try catch video or the exception handling video, the scope of I, which is this variable, is scoped in between these brackets for the try block. We do not have access to I in this scope right here. Okay, so we would need to kind of create I out here, for example. So we can say let I, and we can say maybe I equals 1 over here without the let, where we're not actually declaring the variable, right? And we're declaring it out here in this outer scope, which is accessible to kind of all of this code. And if I rerun this, we'll see that this actually does work. And I stop at 5 here because I am... so because I am just catching it because the loop doesn't actually continue, which is kind of another issue with this code as well. I didn't even realize that at the start. I was so focused on the scoping. So we never actually get a chance to finish this loop either in this scenario because we jump straight out of this entire try block which the loop is actually inside. In the previous case, if you just rewind the video, you'll see that the loop is outside of the try block so that we actually can continue with that code outside of the try catch kind of block. Okay. Definitely a tricky one. I wanted to show you both of these ways just so you can kind of see how things can get a bit tricky with the scoping. We'll see more examples with this in the future. All right, let's go to exercise 2. So for this one, we want to assign an object to a variable called user, which is this object right here. So this object looks like it has a name property with Misha, an age property with the number 22, and then a settings property which points to an object which itself has a color property which is pointing to blue, okay, or a color key pointing to the value blue specifically. Then we want to log out creating user. We want to try to log out this particular combination of property access. So we want to grab the user object, then the profile, then the color, okay? And if you look at this closely, you might be able to see the issue. We then want to log out user created, want to run the code and see what happens, right? And then we need to figure out how to fix this code because in theory, this is probably going to be an issue. And we're not allowed to kind of modify the user object and really change any of these lines. We can't, for example, try to access something different or change this object over here. We just need to probably surround this, with a try catch block so that you can actually get it to work and see what the error is. So give that a shot yourself and see how far you can get. Okay, so first things first, we want to create a user object. So I'm going to say const user is equal to this object right here. I'll just copy it out. Okay, perfect. And then I want to log out creating user. So I'm going to say console.log, and I'll just copy this, creating user. Cool. Then I want to try to log out this value right here, user.profile.color. So I'm going to say console.log user.profile.color. So if we think about this, we're going to go to the user object, which is here. Great. So we're going to look at this object. We're going to look for the profile property. Okay. So if we look at that, we have a name property, age property, and a settings property. There's no profile property, right? So this is going to be undefined. Okay. Then we're going to ask for the color property, assuming that we thought that this might have been an object. So we're effectively going to be doing this. We're going to be doing undefined.color. Which of course is going to cause an error because we can't try to access things on undefined because it's undefined. There's nothing there. Okay, so this is actually going to give us an error. So let's see that once we actually try to run this code. So I'm going to do console log here, and I'm just going to console log the user created right here. Okay, perfect. So if I kind of pull up my sidebar here, I'm going to make sure I'm going to run the correct file, exercise 2. And we can see that we actually get an error, right? And our program crashes. We actually never get a chance to get to any of this logging down here, user created. So we're crashing because we have a type error, cannot read property color of undefined, which is exactly what I showed right here. We're trying to access color on undefined because profile doesn't exist as a property on this object right here. Okay, so how do we fix this? Well, the easiest way to do this without changing anything is really just to surround this all in a try catch block. Okay, we're not throwing an error here. Just be aware of that, right? Like the previous examples, we're actually just seeing that this might be an error prone code. This is a really, really realistic example because there's going to be ample times when we're working with data that's coming back from another server somewhere, some backend or some database or whatever happens to be. And we might not be sure if everything is really on there unless we check explicitly for every single property. So if we accidentally try to access things like this, then we will actually get an error. There are many workarounds for this that we'll get into in future videos, but for now, this is a really good example to look at. So if we console.error out the error, let's see what actually happens with this. So if I rerun this code here, all right, so it looks like we're saying creating user cannot read property color of undefined. So this actually looks very similar in Node.js because this error message actually looks the same pretty much if I'm using console error or console log. I believe if I change this to console log instead of console error, actually it works the exact same way in Node.js. I always forget that. But if I put a log down here, if I say console.log and I'm saying program complete, for example, just to show you that we actually reached the end of the code, you'll see that we do reach the end of the code in this case, right? In the previous case, if we didn't have this try catch block, as soon as this line gets reached right here, user.profile.color, we would basically crash a program. The entire program would crash. Now, something to note here that's really interesting as well is we never ever get to this line right here, line 20 and 21. Well, 20 is blank, but line 21. We never ever say that the user was created. And this is actually a good thing in this case. If you really think about it, if you can picture a scenario where we're trying to kind of build up a user and maybe save it to our system, if we do need to require that the user has this profile color property, for example, and it doesn't, or maybe we require that a user has a password, for example, which is maybe more realistic, and it doesn't, we don't want to actually create that user. Right? That would actually be a huge bug and a huge problem in our code down the line. We would want to just stop, break everything, drop everything, and kind of log out an error message or let people know that something went wrong and actually deny creating that user, for example. Okay, so this is actually really good that we don't get to this line right here in this case, but we can still kind of recover, let people know, log it out, and continue accepting maybe other users that might be formatted correctly, for example. All right, cool. So let's go to the final exercise for this video. So this one has a bit going on in here, so let's take a look at it slowly together. The first thing we want to do is create a try block that does kind of the following things, right? We want to create a variable called number and initialize it to the number 1337. Then we want to add a random number between 0 and 1000 to this number that we created. Then we want to log out the number, right? If the number is less than 2000, so we're kind of doing a conditional check here, right? If the number is less than 2000, then we want to throw an error object with the message you lose. Otherwise, we want to log out kind of you win without throwing any kind of error at all. So this is kind of like a 50-50 game almost, or not really 50-50 in this case, but kind of like a heads or tails flip where we might get over 2000 or we might get under 2000. We're going to do different things in each scenario. So we want to create a catch block that catches the error and logs it out. And then inside of the catch block, we want to log out the number as well. All right. We also want to see kind of what is the issue with this code, right? Like if you run it a few times, try to see if you can tell what might be an issue. And this is something that definitely comes up a lot, and which is why this type of programming is very tricky. And try to explain this like in English in your mind, like what is the issue, right? Like if we saw this code in real life in our code base somewhere, or we were working on this for one of our applications, where could this kind of get us into trouble? Right? So how can we also fix it so that when we access number, so we can access number in the catch block? So as I mentioned before, a scoping issue is going to come up as well here. If we want to actually see what our number is inside of the catch block, we're going to kind of have to think about where our number actually lives and can be seen, and maybe take it out of the try block as a hint. So give that a shot. Quite a lot going on here. Then we'll go through it together. Okay, so let's go ahead and get right into it. So try is the first thing we want to do, looks like. I'm just going to add a catch here because I know that there's always a catch with a try. We want to create a variable called number and initialize it to the number 1337. So I'm going to say const number is equal to 1337, just like that. Actually, I'm going to say let number because I realized we're going to have to add a random number between 0 and 1000 to this. And we can't modify a const, so we'll do let. So in order to generate a random number between 0 and 1000, we saw this in previous videos, we can kind of use the math random function as well as the math floor function. Technically, we don't need to floor the number because if we get a decimal number, that might be okay in this case, but I'll just floor it just so that it looks nice, okay? So I'll say const random number is equal to, we're going to take the floor of math.random multiplied by 1000. I believe this is actually going to get us to 999. So I'll actually do 1001 just so we go all the way to 1000. I'm pretty sure that's correct. I always get off by one on these. So hopefully you can fact check me that I'm right on that one. So now that we've generated a random number, so this is going to be anything between 0 and 1000, right? This is going to be 0 to 1000 right here. We want to log or add that to the random number and then log it out. Okay, so we're going to say number is plus equals random number. And then we want to console.log out the number. And we want to check if the number is less than 2000, we want to throw an error object. All right, so we're going to say if the number is less than 2000, then we want to throw a new error object with the message you lose. Okay, and if it's not, then we're not going to throw this error. Right, so then we want to create a catch block that catches the error and logs it out. So we have the catch block. We're just going to do a console.error, and we're going to log out the error message. And we also want to log out the number. So I'm going to say console.error, and I'll do template string in here. We lost with the number, and then I'll just say number. Okay. So we'll see an issue here in a second as well. There's a couple kind of issues with this code. So let's run this and see what happens. So if I clear this out and I run node and I say exercise 3. All right, so this is kind of weird, right? I was kind of hoping this would happen the first time around, and it did, right? We have what looks like a working program, right? Nothing crashed, nothing broke. We didn't see any of these errors. Everything seems very rosy, right? We got 2,186, definitely not less than 1,000. So our code doesn't throw anything, right? All right, perfect. So let's run it one more time. Oh my gosh, explosions, right? So we get our error here. And we say you lose. Okay, so we lost because we got a very small number, but we also get another error down here. And I know my face again is covering a bit of this, but this is the important part that you should be able to see, which is a reference error. Number is not defined. All right, so let's kind of deal with the first question here before we try to fix that reference error. What's the issue with this setup and code? Well, I guess this is a tricky thing to reason about, but the issue here is that this code will sometimes cause an error and sometimes not cause an error. So if we didn't have this code inside of a try-catch block, for example, and let's say that this code wasn't even throwing an error directly, right? We would potentially sometimes have an error in our program, and maybe that chance is only like a 1% chance, right? Now, you can imagine that these types of errors are absolutely infuriating, and they totally are, right? This is kind of what you hear of when you hear of like bugs happening in program or hard to find bugs or people kind of hacking programs, right? There are sometimes holes that can appear in programs that sometimes happen, sometimes don't happen, but maybe most of the time everything looks totally fine. Right? I think I gave a couple examples in the exception handling video where maybe a lot of the time as you're testing something like say a spacecraft is working a-okay, but then maybe on launch day you get very, very unlucky and a whole bunch of series of things happen that you never tested for, and it may be the shuttle that you're launching or the satellite that you're launching or something really bad happens and a fire happens, or maybe the satellite doesn't get deployed, or worst case scenario, the whole thing kind of explodes, right? Which has definitely happened before. So that is a very scary scenario. And this is an example of how that might happen, right? You can imagine if we lower this number down to something quite low, right? This would only happen very, very few times out of the hundreds of times that we might actually run this, right? The probability might go to 1% or lower, depending on how low we go with this number and the range of our numbers that we're actually testing with. Now, in this case, it's not really an issue because we know the error, right? We're quite literally throwing the error ourselves. But in many, many cases, as we'll see as we're programming, we might not even know that there could be an error with the code that we're running inside our code somewhere. And if we don't have that code that even has a very, very minuscule chance of causing an error inside of a try-catch block, then it will quite literally crash our entire program, right? And that is probably the worst case scenario, and those types of bugs are absolutely infuriating and very, very hard to track down, because even if you try to run your program in many different cases, you might not even be able to recreate that crazy scenario that actually caused a crash. So it's always a good idea to kind of really think about the code that you're running and ask yourself, is there a way that this code could ever conceivably cause an issue or an error in our program? And especially if it's other people's code, like in a library or something, which we'll get into in future videos, that you're running where you're not really sure if it can cause an error, it's usually a good idea to kind of be very careful with it and ask if it makes sense to put inside of a block like this. Okay, I can't count the number of times where I've built applications where I just assumed everything would kind of go the happy path or the rosy path, and then some freak thing might happen, or someone clicks the wrong thing in the wrong order or something, and everything kind of comes crashing down, and I have to restart the entire application. Okay, so definitely some important points to think about there. Now, for this second thing, which is how can we fix it so we can access a number inside of the catch block, we mentioned that there's a different scope here than over here, right? So these are in two different scopes. So in order to actually make this work, the simplest solution really is just to take a number and put it outside of the try-catch block like this, so that it's available in both of these scopes. And this reference error should go away as a result of that. So if I run this, what we'll see is that we actually have that reference error go away, but we also finally get this "we lost with the number 1805" printed out, because we actually are able to get to this line. Because very similar to in a try-catch block or any code without a try-catch block, if we have something like this, where we try to access something and it causes an error in our program, if that thing is not surrounded itself in a try-catch block, it will actually crash the program. So in order to actually have caught that reference error before, we would have had to surround this in another try-catch block. In this case, we actually know the error, so it doesn't really make sense. You can end up in crazy situations with nested try-catch blocks, kind of a try-catch inception kind of thing. So we won't get too deep into that. Just wanted to show you that now that reference error is gone, because we actually have number in the correct scope, and we can actually get the correct console printed out for the very end of our program here on line 29 in my case. Okay, so I know that that was quite a lot going on in a very kind of short amount of time. As we're kind of going through these videos in the second half of the series, there's a lot of things that we're able to mix together now that we have a lot of the building blocks of programming done together. We're actually going to build on this again in the next video, where we're actually going to use this concept with a thing called async await, which is a new feature in JavaScript, which allows us to work with promises in a much easier way. But we needed to actually learn exception handling to actually work with async and await, because unlike vanilla promises, which we saw previously that have a dot then and a dot catch, there really isn't a catch equivalent for async await, except for using the built-in try catch block like we've seen right here. So in order to actually catch those errors that might happen with promises like we would with a catch block in promises, in async await syntax, we actually need to know this exception handling syntax. So I hope you found this video valuable. If you did, I'd appreciate it if you liked the video and subscribe to the channel. So in that next video, I'm super excited to actually get to working with async and await. It's one of my favorite concepts. I have a whole bunch of exercises planned for that as well. And now that we know try catch, we're all ready to get to that video. So can't wait. I'll see you in that one.